This is a quick review of something called the chain rule. The chain rule is a technique that you learn in Calculus 1 for finding the derivatives of kind of complicated functions that are formed from taking one function and putting it inside of another function. For starters, it's important to realize that the chain rule says something about what happens when you have a function that's made by composing two functions. So we need to think about composition of functions. So if you have two functions like, let's say, f of x is equal to, let's say, the tangent of x, and suppose that g of x is equal to, let's say, x squared plus 3, then if you write f of g of x, we sometimes think of that as f composed with g. And what it means is you put g of x inside of f of x. So in other words, instead of doing the tangent of x, you do the tangent of x squared plus 3. And we often speak of f of x as being what we call the outer function, and g of x is the inner function. So abstractly, the chain rule says that if you want to take a derivative of the composition of two functions, what you need to do is you need to take the outer function, take its derivative, and then plug the inner function in place of x in that formula. And then you need to multiply the answer by the derivative of the inner function. So that's an abstract statement of the chain rule. Now we'll do an example of it. For our first example, we'll proceed really formally. In other words, we are given this formula, h of x equals the sine of x squared plus 5x. We're going to actually think of it really carefully as what is h of x? Well, it's f of g of x. And in what way is it f of g of x? Well, if f of x is equal to the sine of x, and if g of x is equal to x squared plus 5x, then think about what f of g of x is. It's going to be take x squared plus 5x and put it inside of the sine function, and that gives us exactly the thing that we have right here. Okay, so before we can take the derivative of h of x, let's think about what ingredients we need. The chain rule says that the derivative of f of g of x is equal to f prime with g of x plugged in place of x, and then multiplied by g prime of x. So basically this means that we need to know what f prime is, and in this example, f prime is going to be the cosine of x, and we also need to know what g prime is. G prime is going to be 2x plus 5. So all that's going to happen is we're going to take our formula for f prime, and we're going to plug g of x in place of x, and then we're going to multiply that answer by g prime of x. So in other words, h prime is going to be equal to, again, we take the derivative of our sine, that's cosine, but instead of putting an x there, we put x squared plus 5x. And then afterwards, we have to multiply by g prime, so that's 2x plus 5. Pretty common mistake that people make is sometimes they accidentally differentiate the thing inside of this cosine right here, but that's not what the chain rule says. The chain rule says that you put g of x inside of f prime, not g prime. So that's our first example. Here's another example. You can think of h of x as being f of g of x. In other words, you have some outer function f of x, and you have some inner function g of x, and the outer function is going to be 1 divided by the square root of x. I'm just going to actually call that x to the minus 1/2 power. So that's 1 divided by the square root of x. The inner function is g of x, and that's going to be equal to the tangent of x. So again, we need to know both f prime and g prime in order to get our answer, so I'm just going to do that right away. So what's f prime? F prime is going to be minus 1/2 times x to the minus 3/2. So that's going to be minus 1/2 times x to the minus 1/2 minus 1. And then, of course, g prime is going to be secant squared of x. Okay. So what do we do with this stuff? Well, it's the same chain rule that we had before, and I'll write it at the bottom. So in other words, h prime is going to be equal to f prime with g of x in place of x multiplied by g prime of x. So now we're going to use that thing. So what do? I need to take f prime, and instead of putting an x there, I need to put tangent of x there, because after all, that's what g of x is. So it's going to be minus a half times tangent of x to the minus 3 halves. And then what do I do afterwards? I have to multiply by g prime. And how do I multiply by g prime? Well, I just stick secant squared of x after that. So that's it. At some very intuitive level, one way to think about what we have here is that basically if you have a function that looks like h of x equals some expression to some power p, then h prime of x is going to be p times that expression to the 1 less power multiplied by the derivative of that expression. Here's our last example. I'm going to think of this one pretty informally. In other words, I'm not going to write out all the details of what's the outer function f of x, what's the inner function g of x. I'm just going to mention that in general, if h of x is equal to sine of something, where that star represents any function you can imagine, then h prime should be equal to cosine of x, or cosine not of x, cosine of star, multiplied by the derivative of star with respect to x. So in other words, sine of x is our outer function, the star is our inner function, and so what we've done is we've taken the derivative of the outer function and plugged star in place of x, and then we multiply by the derivative of the inner function. So in this case, what that means is that h prime is going to be equal to cosine of the square root of 3x plus 5, and then we have to multiply by the derivative of square root of 3x plus 5. So I'm going to just point out that this thing underneath is going to be the derivative of 3x plus 5 to the 1/2 power. That's what's going after this cosine. So what's that going to be? Well, it's going to be 1/2 times 3x plus 5 to the minus 1/2. And then I have to multiply by the derivative of the inside, which happens to be 3. So in this problem, I've actually done the chain rule inside of the chain rule. And that's one reason why it's really helpful to be able to think about this stuff at a more intuitive level, rather than having to write out all the formalism of the individual steps.